Water Action Volunteers Program. And I guess I didn't properly introduce her before because I'm going to do it right now. So she has come, she spent a long week data crunching so that she can share a lot of this with you today. And why is it not?
It's because I shut it off.
Oh.
Well, it
Okay.
didn't. Is it doing it now?
Yes.
Yes,
He's
it's
got
good.
it.
Yeah.
I was going to say we tested
My
it
bad,
before it
yeah.
worked. So with that said, I'm going to turn it over to Chris to tell you all the wonderful things that you guys learned this past year and beyond.
Oh, and I'll echo Jane's words. Thank you for collecting all the data. You overwhelmed us with data, and I'll work my way through what I was able to analyze. And as I said to Jane, I wish I had 200 more hours this week to continue to analyze the data, because as I got into it, it made me have more questions and I wanted to analyze it in other ways. And so some of the ways that I've analyzed it that I'll present to you are a little bit, you deserve a little better than what I'm going to give you, but other things present some interesting questions. So my goal is that I can continue to dive into the data. The program has been around since 1996 in the fall. I came on board in 2001, so just before, the earliest data that I found from Waukesha County was from 2000, and it looked like about 1 or 2 data points, not too many. And then 2002, so you all were saying, who's the 2002? Who's been here?
Richard.
Richard.
Oh, he left.
He left, oh, okay. So one of the things I have in my hand here, for the program, we have, as you know, we have the 3 levels of the program, the entry level introductory monitoring, level 2, and then the level 3 special projects. So for level 2 and level 3, we have the ability right now to create site-specific reports after each season. And one of the cool things that's going to happen with the database change is that we will be able to create site-specific reports for everybody come this summer. Really, we'll do them in the winter once that happens. Just to check, did anybody new come in public-wise, or is everybody is wave people?
We're all
Everybody's
wave.
in, nobody's
Yeah.
in. Okay, so what I did in terms of reports, I printed out 3 of each for the specific sites. So if you want, I will hand around reports. If it's your site, take one, and if it's not, make sure the person whose site it is gets it first, and then there'll be 2 extras. So I have phosphorus reports for Cocoa Creek. It's at County JJ, so it's not specific to Cocoa Creek.
It's Nancy
at
and Sue.
You guys. I have Mason Creek at Peterson phosphorus.
That's Rebecca.
But I'm sure they won't.
Okay. And then I have level 2 reports. I have Battle Creek at BB.
That's Richard who left.
Richard left. Okay, so have at it, anyone who wants Battle Creek at BB. Anybody want it? Okay. I've got Oconomowoc at West Shore Drive. I have Bark River at Genesee Lake Road. SUT. Okay. This might be you two. Pewaukee River at Capitol. Yeah. Okay. They were in order of person. That's what I wrote. I have Springbrook at Holiday.
It's Tom, yeah.
I have Genesee at Old Village. That's Tom too, okay. And I have Bark River County P. Square Road.
Here, got it.
Yeah, okay, I've got a different one. So this is the level 2, that's the phosphorus.
Okay.
And then Mason Creek at Peterson.
Oh, wait. Yeah, that's Rebecca.
All right. And apologies if I don't have one for specific. Okay, so what I wanted to do to talk about your data results was to compare your data results to what we know statewide. So this map is showing last year, 2014, a record year for Water Action Volunteers. We had 655 sites monitored statewide in the 3 levels of the program. So there's level 1 is the blue circles, level 2 is the yellow, and then we had 2 different level 3 projects. We had a road salt project that Jane did, and then we had total phosphorus monitoring also that Jane and some folks did. So you all know the goals of the program. This was written just in case there were public folks who came in, but our goal is that we can have all of you understanding what's happening in your local waters, and that you feel confident that you understand what's going on that you can then try to do something to be able to protect those waters or to improve them for the future. So the sites over time, statewide, back in 1996, we had 4 sites in the fall of 1996, and we've seen this huge growth over time. There's a couple of jumping spots here in 2006, we jumped up, and again in 2012. And what happened in those 2 years? 2006 is when we added our level 2 program. 2012 is when we added our phosphorus monitoring. So you can see when people were getting on board and doing those other options. For you guys, Waukesha County, the earliest data, again, that I found one data point in 2000, and then I found 2002 and on, and you're seeing a similar increase over time with 42 sites monitored in 2014. If you prefer to look at it this way, you can see where you all lie. I didn't label them because there are too many to be able to read it, but what I can tell you is that there's 22 different streams in 9 different watersheds. So, let's see if I can do it. Anybody, we don't, the Aspen River, we have a Oconomowoc here, right? So we did Oconomowoc, we've got, what do we got? Mukwonago, Middle Forks Fox, Upper Fox, there's a Menominee over that way. I swore I would remember what that is, but I don't remember what it is. Help me out.
Battle Creek,
Battle
yeah,
Creek.
Bark River.
Thank you. I was like, oh, I don't need to have the name on there, I'll remember. So you are well spread out over the county. And you all know what's monitored. Again, in case the public had come, here's what you all monitor. You know that the 6 things in level 1, the flow, the habitat, water clarity, temperature, macroinvertebrates, and dissolved oxygen. If you are not familiar with what folks do in level 2, if you are a level 1 person, the difference has in the past been level 2 folks will get a dissolved oxygen meter, a pH meter, and they get this little device called a tidbit, which is really only about this big, and it collects temperature every hour from the time we tell it to till the time we tell it not to. And then transparency is the same as level 1, and then the level 3 projects for the bottom 2, the phosphorus is that bottom middle. Here's the vial. Who asked about how much acid? Here's how much acid, little vial of acid getting added to the sample, and then conductivity is being monitored in the lower right. If anybody is interested, Lindsay Albright is our new level 2 coordinator, and she said she has 5 level 2 kits that are actually the meters. So if you're interested in moving to level 2 and you wanted to get in on a meter before we stop buying them, let Lindsay Albright know, and she will come out and teach you how to use it and set you up with the equipment. Okay, so what do we have for data? We have over 13,000 field visits that people have made in the last 17, 18 years with WAVE, plus thousands of level 2 site visits. And the reason I don't have an actual number for level 2 is because of those continuous temperature monitoring devices. Just for the level 2 sites sitting in this room, there was over 70,000 observations because it's every hour. So it overwhelms the computer when we try to say how many observations have been made in level 2. So thousands and thousands and thousands of observations. Within this county, you've made over 2,500 observations, site field visits, to look at the water's health. So thank you. Okay, so transparency. Things I think you know, but just in case you don't, we'll go through it. So every stream has a baseline transparency. And like Jane was talking about, there's certain streams that she knows are the problem children. However, since each stream has kind of what is expected in that stream, then the life that lives in that stream is expecting the clarity to be what it is. And probably it means that there's probably warmer water temperatures, which probably means that you have a different fish species that are living in a cloudier stream than in a cool trout water stream. But what happens is if you have your transparency that's normal to that stream and it changes for days or weeks or months from what it normally was, then you're going to start to see a shift in what organisms can survive. And that's when there could be a problem. Or if you have, say you have a really cloudy stream and you wanted it to be trout waters, you need to do something to make it not cloudy so that it can be cooler so that the trout can live there and spawn appropriately. So we're looking for changes, either desired changes that you would like to see by management or changes that happened due to land use and changed what you were seeing over time for the transparency. So the turbidity is the cloudiness of the water. So site feeders, it can affect the water temperature, it can affect plant growth. If the plants need the sunlight to respire or photosynthesize, then if they can't get the sun, they're going to be affected. And you all know, bottom left picture is going to change, so you all know how to use a transparency tube. If it's cloudy, you can't see the black and white disc. If it's clear, you can. Same thing, since you all have done this before, you know this is your transparency tube. If you can only fill it up a little bit, you know the water clarity is poor. And on the other side, if you can fill it up a lot, you know the water clarity is good. And hopefully you've all seen this chart in your methods packets. What it is we're looking at the water turbidity here and then time. And what somebody did is looked at a number of different scientific studies and kind of put them together in one chart. So
Chris,
they say,
that isn't what they did there. I checked into that. I did the literature research on that, and that's based completely on a model. We tried to apply that in the Root River watershed restoration plan, and at best, those axes should be taken as illustrative because there's no data to support that
So I have-
particular chart.
Let me explain what the way that I explain that it means. If you have low transparency or high transparency, low NTUs, this is clear water. At days or hours or days, fish are going to start to show signs of stress. When it's days to weeks to months, then there's other things happening. And I agree, it's illustrative of what's going to happen, but it's written in a box because there are different studies on different kinds of fish that it's going to happen at a different point for different kinds of fish. So they might, one kind, salmon, might swim away because they can't, they don't like the temperature that's happened when it gets cloudy for a number of days. But another kind of fish might still be fine. Maybe a bass isn't going to leave. So it certainly is not specific to a kind of fish. But eventually, if you end up with months of really cloudy water, then things could die. That's the general point. So here's something, and I did this research, so I know this is out there. This is based on a compilation of research. If you'd like it, I can get you those. These numbers are the NTUs, and the nephelometric turbidity units, which is the conversion between your transparencies in centimeters to the cloudiness of the water. So I know that there's a study that says at 12 NTUs, plant growth is hindered in a certain kind of plant. I know that there's studies that show between 8 and 20 NTUs that brook trout are using more energy to try to find their food. One of the ones I find pretty interesting is 40 to 50 NTUs, little walleye actually survive better because they can hide in the cloudy water. So there's not always a bad thing that's happening when the water gets cloudier, but there's a number of different things that happen as you get cloudier and cloudier water that tend to be things that are not so good for the aquatic organisms. So what do we know about statewide versus Waukesha? I'll do this for each of the parameters that I'm going to talk about, is have the statewide versus Waukesha County. So we've got almost 11,000 observations of transparency statewide, 2,200 for Waukesha County. Both of them, we've got some waters that are really cloudy, some waters that are really clear. So wide range. The average is slightly cloudier for statewide than in Waukesha County. But if you look at, here's our less than 10 NTU, that's biologically, things are happy at less than 10 NTU. I didn't find any studies that showed that there was negative things happening. For the state, it's cut off here, 70% of statewide data say that the water is less than 10 NTU. Almost 3/4, just over 3/4 in Waukesha County show that it is less than 10 NTU. And then we've got lesser and lesser percents as we get to these higher numbers of NTU. So again, the thing about this though is how long and what was the background at your site and how long is it staying elevated. So I don't know how close or how far folks live from your sites, but one of the neatest data sets I've seen is somebody who was working at a nature center and they went out every day and they tracked the rainfall and they tracked the transparency and they could see how long it took to get back to normal. And the question would then be, how long does it change over time? 10 years ago, did it only take 2 days to get back to normal after a 1-inch rain? And now does it take 7 days to get back to normal? So that's the kind of thing that the more data you have, the more interesting picture you can start to see about a site. if you want to know specifics for each of the parameters, I will also show you the sites of who should be represented in the room, so you can see where you lie. They should be hopefully in alphabetical order if I did it right. Here's 10. So 10, anything below here is good. What the yellow bar represents is the mean of your data, and then the top of the blue bar is the maximum you saw, the bottom of the blue bar is the minimum that you saw. So in this case, the sites, and Jane already said it just by having been out there monitoring, we know Cocoa Creek is one of the sites that we're showing something above 10, which could start to be in that plant growth being hindered, or the brook trout if it was a trout stream. We know that the Mason Creek sites are above that 10, and we know far at the end is Zion Creek. Does that, folks who are monitoring there, does that make sense from what you're seeing?
Well, Mason at Northwoods and Mason at Peterson are just a couple blocks apart, and there could not be any problem between Northwoods Drive and Peterson.
The
So that's
difference-
just a timing issue
yeah,
of when
so that's
she's
exactly
doing the
right.
samples and
That's-
I'm doing them.
That's absolutely right. So that's a weakness of the fact that we only can go out when we have time to go out to monitor versus having continuous data over time. So you're absolutely right. We're gonna miss things or see a little bit of a different picture depending on when somebody goes out versus when somebody else goes out. So very good. It's a weakness of the fact that I can't say to all of you or Jane to all of you, you must go out every day, every hour. We want that information. So you're right. We know we recognize it.
It's saying, I'm looking for trouble because we're trying to solve North Lake's problems.
Yeah.
So I would focus after a rainstorm.
Yep, and that's what, with the road salt project, that's what we do too, is we tell people to go out and monitor when we think it's gonna be bad water quality, and it's exactly that, we're looking for trouble. We're looking for problem waters. So there is the opportunity, if desired, to bias your sampling or to paint a picture of, hey, it doesn't look good at all, versus, oh, I'm only gonna go out on sunny days, or when it's been sunny for 2 days prior, which maybe all these sites here that have no range, maybe they only go out when it's been nice for a week because they don't want to get, safety-wise, right? If you don't want to get in a stream that's too deep or too muddy, maybe we're not getting the whole picture. So we have to recognize that that's something that's a possibility. Okay, I'm going to move into my favorite, biotic index. So you all know it's a water quality rating based on the organisms without backbones that are in the stream. We know that everything that lives requires oxygen, whether it's plant or animal. We know that land use is going to affect our amount of oxygen in the stream based on, for instance, nutrients. If we have personal fertilizing in our yards or on farm fields, phosphorus, one nutrient, sticks to sediments, it runs off into waterways, and that can affect the amount of oxygen. If we bring fertilizers, we grow plants in the stream, we get more oxygen in the afternoon, we get less oxygen at night because there's more things respiring and using oxygen in the night. One of the things we have to recognize, our air, it's about 21% oxygen, so 200,000 parts per million. In the water is only 15, and that's on a good day. When you all measure dissolved oxygen, you're usually seeing like 8 milligrams per liter, 10 milligrams per liter, 12 milligrams per liter. That's equal to parts per million. So there's way less oxygen already in the water system, and these organisms are relying on that to survive. So if there's a problem that we cause by our land use that shrinks the amount of oxygen, then we can affect the organisms that are really reliant upon the oxygen, like this stonefly. Anybody get stoneflies at their sites? I didn't look at your organism specific. Jane sometimes gets them. I don't know if you have any there today.
There was one that came out of the stream here
Oh, cool.
in the pan, but I couldn't find it today.
Oh, okay. So they're cool. If you do see them, they do push-ups. They have their gills under their armpits, and if they want to get more oxygen, they do push-ups to move oxygen over their gills. And you can see them literally in our ice cube trays doing that to increase their oxygen.
Can I
They
ask you
care
a
a lot.
question?
Yeah.
Each of these different species, is there data on how much parts per million oxygen that they need?
I don't know about
Yes.
specific parts per million, but in general, so the way that our index works is empirically, this researcher, Hilson Hoff, is his last name, he went out and he said, okay, I know there's good water quality at the site from whatever he knew, and so he said, I'm finding stoneflies and I'm finding this specific kind of mayfly, so I'm gonna give them a good water quality rating. So we don't from him, we don't necessarily say, oh, we know they need 10 parts per million and they need 20 parts per million. There could be some research studies. I haven't looked into the research to see if there's specific, but what we do know empirically that they need more, like for the stoneflies, there's a water stream over by Devil's Lake State Park. I know I go to the pour over the rock where it lands, where the water lands going over the rock, I can find stoneflies. If I go 6 inches to either side, I'm not finding stoneflies. So I know that they're in the highest oxygenated spot. And so there may be data that says specifically, but I don't, generally what we say is, oh, we just know that they need more oxygen.
Okay.
We had a quirk on North Lake where we lost a bunch of crappies because the water was over oxygenated.
That can happen as well,
And
yeah.
it hit 20, and that was a problem, was windward shore.
Yeah.
In spring after the water.
I'm surprised 20 is high, but it's not, like, Hoover Dam, the fish get, what do they call it, bulge eye
Yeah,
disease?
You'll see it at 140% saturation is
140%.
when, if you get above 140% dissolved oxygen saturation, you'll start to see bulging eyes in fish, and you'll start to see fish kills there.
It was limited to crappies. So
It's
they must
interesting, because
be
I would think of the
more
crappies being kind of a hardy fish, so that's interesting to hear that they had issues because of that. So just to refresh, your water quality, your biotic indices that you do the score for, we get poor 1 to 2, fair 2.1 to 2.5, and good up to 3.5, and I'm ignoring what you might see on your data sheets beyond that. So statewide, we've got over 4,000 samples. In Waukesha County, almost 700 samples collected. The means are almost identical between state and here. Fair water quality is the rating that we see. And then if you look at it by percent, we see about, in Waukesha County, about, say 1 out of every 5 samples is good, 1 out of every 5 is poor, and then you're looking at, just over half are fair water quality. Statewide, we actually have more good than we do in Waukesha County if we're comparing that way. And then to look specifically at what you all are seeing, and I'm gonna throw on the colors here. So we've got poor in red, our orange is fair, and then good up here. So we are seeing, again, this is your mean, this is the range for your site. So like, for instance, Bark at Genesee Lake, that's quite a range that is being observed at that site. But our mean is within that fair range. But what to me is curious is what's happening at certain times to cause such a range. And same with a couple of the other sites, Genesee, Bark at Sawyer. What's causing that range? One thing that came to mind, and I didn't check yet, this is where I wish I'd had more time, was what time of year are the samples being collected? So for instance, if you were to collect in a year when there was like an early hatch, and you go out in May and there's a lot of things already flying around as adults, and they're not necessarily findable in your sample, you might get a lower score at that time of year because you're not collecting them in your tray. Or there could be other factors that I haven't thought of. But just to me is curious is what's causing these big ranges and why is it not staying kind of closer in at each site?
Just the difference in detectability between spring and fall.
What is the difference? Or
No,
you're
no,
saying
that'll be a big factor
Sure, we
because
could,
the
yeah,
critters
separate
are so
out.
much smaller in the fall that they're hard to detect.
Yeah, so
And
if you're
that-
going out
and-
early in the fall versus like in the end of October and you're missing
Yeah.
them happening, that's true. There's
Yeah,
there's a
there's
difference. The water quality score tends to be better in the spring sample than in the fall sample from the biologists who are doing the collection. So that's and I didn't even think to separate it out by spring and fall. I should have done that between the two. That's a good point. Everybody get a chance to see where your site lies. Putting in a plug for the Jane and the Scuppernong Creek site. So do there's Bark at Nixon,
Yeah,
Scuppernong Ice Age Trail. Is
That's
there a third
it,
one?
just the two.
So there's two sites in Waukesha County that we installed these nice signs. Jane and Karen and I last fall hammering them in. And the idea is that we wanted to share your good work with other people and try to let them know what's happening with the Water Action Volunteers Program, as well as educate folks about what is a watershed, what's non-point source pollution, and being able to see what it is that you all do. So if anybody has smartphones, this little code right there, you can scan with your smartphone and it will bring you to a website that's set up for using with mobile-friendly devices. And there are photos with just one sentence that says, volunteers in the WAVE program monitor temperature, and there's a picture of somebody doing it, and then they can go to the next parameter. So there's 8 parameters they can see. They can also see the results for any site that they would like to. So a plug for
Is that
visiting.
Scuppernong?
That's, yep.
Just across the way from Ottawa Lake Campground?
No, this is Scuppernong, that's Scuppernong River down there. This is Scuppernong Creek, so this is kind of between Wales and Dousman. Scuppernong Creek kind of meanders in through there.
And I'll say it's the first site where we got a random person to tell us that they were there and that they were interested in doing monitoring. So I don't know if that person's gonna get involved this year or not, but.
I never heard back from them.
Oh.
But
Okay, so for oxygen, again, everything needs oxygen to survive. Same thing with the biotic index connection to oxygen. We know that water at a certain temperature can hold a certain amount of oxygen. Colder water can hold more than warm water. When I teach, I usually use the analogy of a cold soda on the counter on a hot summer day versus, a soda on the counter for 4 hours on a hot summer day versus the fresh poured one, and you get the more bubbles coming out in the cold one. Same principle applies. More gas can dissolve in a cold liquid than in a warm one. So we want, if we were trout, we want colder streams to swim around in because we had more oxygen. Saturation. So Joe's talking about 140% saturated. So water, if it at a certain pressure and temperature can hold a certain amount of oxygen, when it has the amount that it's supposed to be able to hold at that pressure and temperature, it's called saturated. It can be supersaturated if there is more oxygen being made than is able to be diffused off or used by organisms than it's making. So if there's nutrient pollution and there's a lot of plants and they're hot, sunny summer day and they're making a lot of oxygen, it's probably going to be over 100% saturated at that point. So you probably, how many people have seen more than 100% saturation? A couple people. I usually say they're happiest with 80 to 120, and then we get the bulge eye. That's
Yeah, you
bulge eye
start seeing
disease
that
or
at
something.
about 140.
140. And then it's going to change over 24 hours, right? You know, just before dawn is the lowest because everybody's been breathing at night, nobody's been making oxygen. So in nutrient polluted streams, you're going to get a wider range. You're going to get lower lows in the morning and higher highs in the afternoon of your oxygen because of the nutrient pollution or things that are affecting the oxygen that we do on the land. So just to give us context, so below 2 milligrams per liter, pretty much aquatic life doesn't like it. They need more than that. And again, milligrams per liter is equal to parts per million, so 2 parts per million. Below 4 or 5, some things are going to be okay. Some kinds of fish like carp and whatnot, even bass will be okay, but they're not going to be happy for a really long time. They would prefer it to be a little higher. When you get up to 6 and 7, trout are doing well. That's a state standard. We can't drop below that in designated trout waters. And then there's actually some specific classifications for water standards. I'll show you those. So these are by state standard classifications in Wisconsin. So trout waters have to be no less than 6 when it's not spawning season and no less than 7 when it is spawning season. If the waters are designated as fish or aquatic life, you can't drop below 5 milligrams per liter. If they're designated as limited forage fish waters, can't drop below 3, and if they're designated as limited aquatic life waters, they can't drop below 1. So that's pretty generous, right? We'll call it not much is living there. So what you can do is we can find out what your streams are classified as, and sometimes it's general and sometimes it might be a trout water, and then you can see, hey, my stream I should never see below whatever number at my site, and you can judge based on that.
Question.
Yeah.
All our streams, for the most part, are shallow. If you're in a deeper river, so to speak, does the oxygen like a lake? go
can.
up and down ladder?
It can, but generally, we work under the assumption that streams and rivers are well mixed, which, because they're moving,